This session is organized by Botlab. Botlab is an organization that offers bespoke trainings in data science and cybersecurity. We also offer technical trainings that are accredited by Huawei in conjunction with other training platforms, and also we provide data protection services. And the last thing that we provide is data science as a service. So we analyze data on behalf of clients. We would want to get started. David is a personal friend, and David, I forgot to get your bio. If you need to get more information about David, but David used to work in Kenya for Oracle, and also he worked in the US. He worked for Apple, among other organizations that he's worked for. He has over, I think, 15 or more years of experience in the IT space as a techie, and he's very good at modeling, especially on the financial side. So he'll take us through this session today, and I hope you'll enjoy it. David?
Thank you very much for giving me this opportunity to share with you my views and methodology on data cleaning. This is by no means the how-to guide on data cleaning, but rather my approach and the kind of mental process that I go through when presented with a data set. Let me start by saying that you probably know that there is nothing like a clean data set. And basically every piece of data that you get, you need to clean it for one reason or the other, depending on what your outcome is. I even go as far as saying that a clean data set is a disservice, because then it robs you of a chance to get to know the data that you're going to be presenting and or whose findings you're supposed to give. So it is actually a good thing that we have to clean data and present it and get to know it. There's a saying that if you torture data long enough, it will confess to anything. And this is basically a chance for you to torture that data, to get to know that data, and to be able to start presenting its findings. My methodology today is going to be pretty hands-on. I have a data set that I will walk you through how I cleaned it. There are chances for you to ask questions or to ask why I did what I did. But all in all, I just want you to have an idea of the kind of process that I go through. Now, cleaning data is such a personal thing. Every single one of us is going to clean for different things. But at the end of the day, you want to get a chance to have the data set that you can go into, whether you're an analyst, whether you're a data scientist, or you're a machine model person, or you're a machine learning engineer, so that you can be able to reveal and to be able to present the findings. Now, as I start, let me just walk you through some steps that I got to learn. One is that an analyst, a data analyst, sometimes we get this question, those are using a data analyst, a data engineer, data scientist, and a machine learning scientist. The data engineer basically prepares the data to be presented so that somebody can analyze it. So basically we're dealing with pipelines. We're dealing with ETL pipelines, extract, transform, and load pipelines. A data analyst basically reports what happened. So basically, a data analyst just presents the facts as they are. Data scientist presents why something happened. Because yes, this is what we saw, but why did this happen? And a machine learning engineer presents what will happen. But however, having said that, all the three or all the four people have to have cleaning at their core. I know you know this, but let me say it once again, is that we spend 80 to 90% of the time cleaning data. And my methodology for today is that I have a data set from the Ministry of Health. There's what is from the Ministry of Health website, there's a spreadsheet called the Kenya Health Facility Master List. It's basically a list of all the health facilities in Kenya as of 2018. They are classified, whether they are level 2, level 3, level 4. I basically downloaded it raw. So soon after this, I will jump into my Jupyter notebook and we will start working on it line by line. So if there's any question, you can post it on the chat down there, and let's get started. All right, let's do this. What I have done is that I've gone through the cleaning first. I have isolated what I would love to share with you and show you. Have some of my own tools in there that you can ask questions about. And then I'll just walk you through that, and we can leave quite a bit of time to ask questions. So I've divided this presentation into a number of groups. So the first place that we always start is to import the libraries. So I've imported Pandas. I'm imported NumPy. And the crazy thing is that I'm not going to use NumPy anywhere in these presentations, but I've done that out of habit. It feels almost like apostasy for you to import Pandas and not to import NumPy. Then I have two libraries that I absolutely love. One is called Missing NO. It's basically for missing numbers to visualize your data set. And then next is Pandas Profiling, which I absolutely love. Now, next to that, I have these two fields here. And this is basically for convenience. So what I do is that I set the maximum number of rows to 500, and I set the number of maximum columns to 500. And I'm doing this for a very specific reason. There are times I have missed on columns, especially when you have data with multiple columns. And by the time you're done cleaning, you realize that there are some fields that you do not see, just by the way they're presented. So this guarantees that you're going to see all the data set as and when we query it by row and by column based on how many we want to see. Now below that, I do something very specific. I check out the versions of each and everything that I've imported. The reason behind this, because sometimes there can be such functional changes in the packages that could actually present different results. So I normally do this as a practice, and I import this. And I also try and work in such a way that if somebody else other than myself is looking at the process that I did or the steps that I did, they are able to recreate results that I got. And I think that's something that is coming, has been in Kenya for a while. We have developers who are, or even data scientists or analysts who are one-man shows. One person does one thing from the beginning to the end, and don't ask questions, don't do anything, just do what you're supposed to do. I'll give you the results, say the results, and they go. But it's imperative as we work as professionals that we work in such a way that our work is repeatable and our results are repeatable. So I run that, and then you see the versions of Pandas, of NumPy, of Missing NO, and of Pandas Profiling. It's also worth noting that if you have any experience on Linux or any of those Linux or BSD, is that you're able to run commands directly inside here. The reason I say this is important because sometimes we don't know exactly where we are. So where we started the Jupyter notebook and where we could be analyzing, sometimes you need to try and find out where we are. So I'm able to run print working directory that shows me where that is. And I'm also able to do ls. I'm able to list the files that are in that particular directory. So in this case, I will be importing this XLS file here, and I'm able to see all of them. So literally any Linux command that you can run it directly inside here. And sometimes in earlier versions of Jupyter, you had to add an exclamation point at the beginning, but the result is still the same. So if you run a command directly, it gives you an error. You can always go back and put the exclamation point. So let's import the data. What I'm doing first is that even before I import the data, I want to get to know the data. So if you notice is that I read the Excel file, but I don't give it any value. The reason is I want to see what that data set looks like before I import it, right? I want to see, what are the columns, what it is about. And it's not always that you import everything in a spreadsheet or in a data set. You may decide and opt to pick the columns and the headers. And that's why I do this, because sometimes before you import it, you want to see, what do I need to change? Do I need to pick particular columns? What do I need to do? So this just gives you a chance to view it. Now, there are options around importing. For those of us who've used Pandas, you realize you can select the columns you want to use. You can also indicate that you don't want any index column because you want the freedom and the elbow space to define that. In addition to that, you can define data types at importing, and that's D types. And in D types, it takes a dictionary, so you can define the data types. Let me also say at this point that you don't have to clean everything in Python. You don't have to clean everything in Jupyter. You can actually clean that file in XLS, or you can in Excel, or you can clean it in CSV. You'd absolutely, there's no rule anywhere that says you have to clean it inside Jupyter or Python in this matter. So you're able to add things. Another function that I've really come to like is sparse dates. And anyone who does any analytics and realize the importance of dates is that it can be quite a headache to decipher down the line. So this gives you the facility within import or read that you can change dates, you can pass dates, you can define index columns. There's a number of things you're able to do. So the more you're able to do upfront as you bring the data in, the easier you'll have a time working on that. So in this case, I'm just giving this an example, is that I indicated I don't an index column and I want index columns 1, 2, 3, etc. And as you know, we always start from 0. So 0 is out, so number 1 is that. And that's what you see here, right? And then I've also defined as index column to be 0. So in this case, the very first field is what it defines as an index column. So in that case, if you're doing your index locator or whatever it is that you're doing, you go by the name. I found that really, really useful sometimes especially when you come to, for example, aggregation or when you're running location. So just give you a quick rundown of this data set. It has the name, it has the official name. Of course, that's a replication. It has a number to that particular facilities. It has the KPH level. Is it a level 2, level 3, etc.? What type of facility is it? Is it a medical? Is it a dispensary? Is it testing, etc.? You know, type of, as you can see, some of them are replicated. And this is why it is imperative for you to see this, because you can decide that I'm out of the official name and the name, I may opt to pick one of them because they're typically identical. And between the facility type and the facility category and facility type, you can decide to pick one either. And then what type of owner or owner type. So all these you can realize, so for you to save time and for you to save your own bandwidth and for a better experience, you may decide to nitpick. And that's why I reckon you can pick the user columns that you want to work with from the beginning. You don't need to bring them in and have to kick them out one by one. You can actually go as far as possible so you're able to get this data. It has number of beds, number of courts. It talks about the county it is, the constituency, the sub-county, and the ward. These are pretty interesting data set, and it has unbelievable implications right now as you understand the kinds of times we are going with. And then it says operational status, is it running, is it not, is it open whole day, is it open public holiday, etc., etc. So at least this gives you a fast place to start interacting with the data and for you to start seeing what it looks like. Now, when you do that, eventually what you'll do, you'll come and import the data set. I think one of the things I really love doing is naming the data frames. I don't know why, it just gives me unbelievable excitement to find a name that I can give the data set. So in this case, I called it Health DF. And once I import it, is that then I come and do the head and just have a look at it, the first 5 records, which should not be, come as a surprise because already we have seen what that looks like up here. We also look at the tail, the last 5 records, and then we get the interesting part. We want to see what the shape is like. So the shape tells me there are 12,376 records, rows in this case, and we have 25 columns. And that's really important because then you can start thinking about, it just starts giving you a feel of what that looks like. The next thing I tend to do a lot is also check the columns. What are the naming of the columns? And what I find interesting is that whenever I have an instance when we have uppercase and lowercase, when I get to querying, I have to hit the shift button to see code and then I have to drop it again. So normally this is one of the areas I start cleaning. I clean up the columns so that they are easy and they're straightforward so that when I start, even if I'm looking for owner type, I don't have to remember whether it's uppercase or lowercase. Something else that you realize is that also there are gaps in here, like owner-type or KAPH-level. These are among the first places that I clean. And I think one thing we can do beyond this, we can also do health DF, pardon me, we can do a healthdf.info so that we can see what data types have been imported. And also this gives you a high level view of the data set on what is being imported, what data type it is, how many null values are there, etc. Now, then comes one of my tools. I love this missing numbers. So missing numbers allows you a chance to visualize the data. So it has two parts. It actually has multiple arguments. If I did MSNO, oh, it's marked down. I just need a code field. If I did that, you can see all the different types that it has, right? So in this case, I just pick matrix and I decide, let me visualize that. And you can see it runs matplotlib at the back. And this just gives you an idea of what each of the fields look like. So you can see the numbers, it can show you where the gaps are. You can see, for example, registration number, there are some that are not there or missing or blank. But this set looks pretty populated, but there are times that you'll see this table just show you all sorts of areas. And also this gives you an idea. And as you get to know the data of what kind of work it needs, it also gives you a bar graph. Now the bar is a bit different. So the bar at the top shows you the number of records that are there in each data set. So you literally can map each of these one-on-one, and you can see, for instance, in service name, it shows you 0. So basically on that, it's just NAMs. And in your mind, you're already thinking, yeah, I need to get rid of that field. Another tool that I absolutely love for initial EDA is Pandas Profiling. This is a bit more advanced and does a lot more work, but it gives you an even better understanding of what's happening inside your data set. Again, remember, we're still exploring the data, we're still getting to know the data. So, and the argument for this is PP. If you remember up here, I imported Pandas Profiling as PP. So I'll come down here and I'll do PP profile report, and then I put the name of the data set in there. So when I come here, it just gives me a high level. It tells me how many variables are there. Remember, we had seen 25 columns. We had seen how many observations are there. We've seen how many missing cells are there, percentage of missing cells. Literally, it gives you a really, really good overview. Now, it's worth noting in this case that if you have a large data set, there's an argument that you can pass to Pandas Profiling to give you a minimum report. We only have 12,300 records, so definitely that's not large enough. It also comes and gives you production, how long it took, what version of Pandas Profiling you're running. It gives an idea about the distinction of each and every field that you're doing. For example, this was code. If you look at the first field we have here, that's code right there. So it basically gives you an understanding of each and every column that we are working with in this case. You then come to the warnings. This can save you a lot of time in your analytics. So it tells you that the code is has high cardinality, which means that there are distinct values in each and every one of them, right? To almost the same number of outlets there are, same thing with names. So this shows you that, and then it shows you the correlation existing. So in this case, it's saying the facility category and facility type have a high correlation, which is true, because you remember we saw literally the same thing, owner type and owner, etc. Missing values is saying that service names are missing literally 12,376. So, and at one point actually even recommends that you delete this, because then if you have so many missing values, then that cannot add, you cannot impute, you cannot use any other tools that allows you to impute what the values look like. So same thing with courts, gives you an idea of the number of beds, of which it says that at least 8,000 are 0.69%. And then courts, the same thing, beds and courts, it shows you quite a number of them that are missing. In this case, there are many hospitals whose number of courts have not been recorded. And this then gives you a line by line understanding of the same data set. If you look at this properly, it looks pretty much what we had seen with missing a no. And the same thing when it comes to metrics and dendrogram. All right. Let me just pause for a minute and see if we have any questions. Do you have any questions right now?
Someone asked, where is the source of the data set?
The data set is from the Ministry of Health. I got it from the Ministry of Health site directly. Any other question before we proceed?
Not that I have seen.
All right, fair enough. All right, then let's get to the next part. What also it does, it gives you, this is basically what we're running, healthdf.head, n is equal to 10. So it counts from 0 up to 10, and then also does tail. So literally you can do this instead of the initial part here. But I guess the more we get to see the data, the more we see the behaviors of the data. If for example, if I came and said 10, and I came and looked at this 10, we will make available we will make this workbook available, the Python notebook available. All right. So yeah, so that's where we are at. So by now we must be able to be in a position to have a bit more information than we had before. We've seen what the numbers look like, what the fields look like, and from here up until now, all we're doing was just exploring the data set. We are not getting to a point where we start cleaning. And that is why we come to aspect number 3. Now, what I would normally do is that I'll take a pen and paper or something else or my iPad, and then I'll scratch based on what I have seen, what do I need to do? And the first place that I almost always start is to clean up the headers and to clean up the titles, to remove the gaps. Reason being is that when I'm querying a column that has a gap, the results tend to be very frustrating. Something else that happens, since I don't know what the data source is, I mean, I don't know how, I know the data source, but I don't know how it's going to behave. I remove the gaps before and after. So for instance, if I come and run .columns, it will show me the names, and I mentioned before, you'll see these gaps here. You'll see owner, you will see open at night, and there's an underscore there, there's not. So what I love is to have some uniformity. So the first thing that I do is I will clean the gaps and the spaces. The next thing I will do is that I'll drop any irrelevant or empty columns. For instance, already here, we've seen there's one that has service names. It's basically 100% missing values. Surely there's nothing we can do much with that. So we have no option but to drop that off. And then other types is, for example, dropping either name or official name, dropping facility owner, owner versus owner type, etc. Right? And then the next thing I'll do is that I will literally go through each and every column to see how many are unique values, what are the numbers, what does the data look like? And I'll show you an example down the line. And then the next thing I would do is that I will remove missing data, which is huge because for example, if you have a machine learning instance and you're training a model and you have missing values, that will definitely skew your results. Let me point at this point that, for instance, the other reason why it's important for you to look through each column is, for example, if you have a model that you want to train, you have to make sure that it's normalized. Otherwise, if you don't normalize it, the field that has the most values is where the model is going to skew towards, right? So if you have 4 possible outcomes, and one of them is 80% of the data set, and then the rest of the outcomes are 3. If you train using that data set the way it is, you're bound to overfit or to have wrong results based on what it is that you put in. So that's the other important part. You just want to normalize it and to look through, and so that you can balance the data set, so that when you're training it, you will then be able to output or get results that are congruent to what is that you want to measure. Then the other part is that I'd convert the data types. This is so important because then you want equal, for instance, when it's reading, when you're doing the PD read, is that it will deduce the data type based on what it thinks it is. Sometimes it will read dates as floats. So then we need to be in a position where we convert the date to not only date time, but also to be able to convert it into a format that we can analyze it. If you're using an LSTM model or you're running anything else, you would want to be able to be in a position to put data that is identical and also make sure that it forms within a particular range so that it can give you the results. Last but not least, save, and save again. This I will tell you from experience. I have had some nasty experience where I've cleaned the data to a point and then go down the line and I made a mistake and I have to import the data again. So you will see what I mean. So in this case, I just go through the usual steps. I'll go through info, which you've already seen before. I'll go through columns. And the first thing that I always do is that I will always seek to simplify the column types. And this is what I'm given, and this is what I want. So basically what I do is that I use the string method. I will make everything lower. I will strip. So what this strip does, it runs both an L strip and an R strip. It basically strips whatever gap is there before and whatever gap is at the end. And also I seek to replace the gaps with an underscore, right? So that by the time if I'm auto-completing a name, it will be able to read that. So initially I just do that to ensure that everything that I want, and then that's when I will place it into the value. So if we come again, that becomes the main, that is what I tend to be very pedantic about this because I've wasted a lot of time trying to figure out why I'm not getting the results or why I'm getting errors, right? Now, as I said, there are some things I want to drop. I want to drop service names. And the reason is, remember we saw service names is 100% missing value. There's zero. So there's nothing it will do to that. So I have two ways that I normally drop. I either use pop, right? It will drop and doesn't, the interesting about pop is that it will not ask you, it doesn't have an in place is equal to. The other way that I can use to drop is I can use health.drop. So I cannot redrop this. So I have to look for something else to drop. So the first thing that I'll do is, for example, I'll check a column codes, and I realize probably I don't need codes. That's something specific to Ministry of Health. So I'll use the drop. So this pop and this drop have identical functionality. It's just that in this case, you want to seek a confirmation. Sometimes you want to run it first to see if it actually drops it. Then once you're sure it does it, and this is one thing I absolutely love about Python and Jupyter notebooks, is that you can see the results first. Then when you're sure, you just go, yeah. And then if you check again, that column is missing, the code column, because probably I don't need it. Same thing with, say I want to drop official name. In this case, I'll just take the easy way out. I'll come here and I will go to official name. I try to save as much time as I can in keystrokes by just copying and pasting. So if we look again, that has been dropped. And in place just locks it in. Now, how I analyze each and every column is that I will do unique. I want to see, for example, if it's the name of a center, how many unique values do I have? And this just gives me an eyeball. Then I want to do a count. Then I know as far as health centers are concerned, I have all of them in place. So I have 1,273, 12,376, so I'm good. So I'll do this for each and every column. And remember, the purpose of cleaning is for you to be able to know the data that you're working with intimately. And I can't emphasize that more. And sometimes all I want to do is just see a list. So I have a feeling. Do I keep the dispensary in? I just want to have a feeling of what the data looks like and what the data feels like. All right. So do we have a question up until this point?
Yes. Question around normalization. Is normalization as we know from database systems management?
No, that's a great question. Normalization is not as we know it in the database system. Normalization in this case is ensuring that you have equal amounts of everything that is in the data set. So for example, say I am training, the best case I can think about is machine learning models. Say I am training a model on whether to predict, let's take an example of a data set I saw recently of pneumonia. You're training a model on detecting pneumonia from X-rays. If you have one type of disease, actually, let me not call it pneumonia. If you have one type, if your data is skewed towards a particular outcome, if 80% of the data set points the results to be one place, then if you train using that model, even when I'd say the model will be biased towards what is majority of the data set as we know it. So in normalization, what you're doing, we're not looking for unique, we're basically looking for equal quantities of representation so we can train the model correctly. So just make sure there are equal parts of the desired outcomes that we're looking at. Are we good? Any other question?
Not at the moment.
All right, fair enough. So the next thing that I do is I have, and the other thing that through this you'll see I have a serious bias towards Lambda functions. And what I like about Lambda functions is that they allow you to do one line of code without having to write a function. So what I'm doing in this case, I'm almost doing an identical thing to the fields that I did here. So I'm doing, making sure everything is lower. I replace gaps. Now, here comes an interesting part. Now, if you go to the county, counties are very interesting. It's because you're going to see counties with single names. We'll see Kirinyaga, we will see Kakamega, etc. But then we have Trans Nzoia, which has a gap. And here is the best of them all. Tharaka-Nithi, which has an apostrophe. So as the person who is cleaning this up, you have to take a decision. Do I stick with the apostrophe in Tharaka-Nithi, or what else do I do? Because that is going to have serious implications on your outcome. Sometimes you have to look for escape characters. The other thing is that if you're looking at county and sub-county, county and sub-county, is that there are places where a county name is identical to a sub-county name. For example, Wajir. There's Wajir town and there's Wajir county. There is Kiambu town and there's Kiambu county. So this kind of understanding, as you check through the data, it will start giving you something to think about. What do I do? For instance, you can get crafty and decide that when it comes to a name like Tharaka-Nithi as a county and a sub-county, you can decide to change one and keep the other, because that is a river that you have to cross when you get down there, when you start doing analytics. So there are things that you cannot do any other way but cleaning, but also you have to start thinking ahead about the kind of work you'll be doing. So in this case, what I'm doing is that I am removing lowercase, I'm removing front and back caps, I'm removing spaces in one command, right? So what I will do, instead of running the same command 4 times, I will just run it once, because I am very hardworking and I don't, but again, there's a rule within Python, don't repeat yourself. So what I will do is that I will run through that. Now, I just did this for the show, the last part. So what I do is that I have a Lambda function allows you, in this case, to replace everything within a particular, within a particular column. And what I do is that I've done an apply. I have a Lambda X, and then I say X, whatever X is, whatever name is here, 1, make it lower. Secondly, strip. And then thirdly, replace space with an underscore. But this last one is just more for demonstration purposes. I don't replace every gap with an underscore. So you may opt or not opt to do this, but what I want to demonstrate this is that you don't have to run this 4 or 5 times. I think the str function within cleanup and within analytics is one of the most important things to have. about, say, about 2 or 3 things that you can put in your Swiss Army knife is understanding how to clean and work around string values, lambda functions, and basically doing querying, the ilock and lock and the rest that we're going to see down the line. So what I did in this case is that I ran this, and then I have since, remember, I have not piped this into the name, so it still is the way it is. So I can say, okay, tell you what, let me remove the replace function. Let me just say, you know what, I can live with the gaps. So what I would do is that I can run that, and I don't have the gaps, but everything else is lowercase. Why? Because I will refer to this over and over again in my queries. Now, so if I then come and send this to the function itself, I will basically be baking it. So if we look in future, if we do df.name, then all the name basically is complied to what we did here. And again, with lambda functions, there's no in place, you just have to put it in there. Now, I call this the laziness challenge. And the reason I call this is because I want to change multiple fields at the same time and not have to repeat this over and over again by column. So what I did is that I came and queried for all the, literally what I did at this point, if I remove that, is if I do that, it'll, okay, I think they knocked something out. Official name, yes, because remember we deleted official name. So I will come here and look for the official name, and I'll delete that. And basically we see what that looks like. And then what I'm saying is that replace the values there by running a large lambda function with the strip and the lower, etc. for everything. So I have to come here up again and also remove official name, otherwise it's going to throw an error back at us. And with that one move, I have turned literally all this into lowercase, into, I didn't remove the gaps, and then I basically stripped the gap between the front and the back. And that is what I do this for, because then I won't see a certain uniformity. You can also take a decision about these alternatives, because it says private practice, NAS/midwifery. So you can decide whether you want to keep this or not. But one way or the other, it's your decision. And I am open for some questions.
Yes.
I see Lillian asking. Go ahead.
Yeah, Lillian is asking, so it means intentionally looking for data that are skewed in various directions for normalization in modeling. Wouldn't it eventually be a biased model?
That's a great question. So it depends on what you want to do. And that's why I say there's a distinction between an analyst and a data scientist and a machine learning engineer. Now, if you're either an analyst or a data scientist, you don't want to normalize it. Right? You want to keep it as is. However, if you're adding some learning, if you're teaching the model how to learn different outcomes, then what you want to do, you don't want to normalize it. You don't, sorry, if you want the machine to reverse engineer correlation between the different categories and an outcome, then in that case you want to normalize it. That's a great question, Lillian. Right, the only times you normalize it is when you want to, if you're using it specifically to train a machine learning model. Other than that, you just want to report the way it is. That's a great question. Are we good, Miss Lillian?
There's another question.
Mm-hmm.
Is there a relationship between normalization and bias, especially in artificial intelligence? Example, computer vision models where the AI is biased towards one object over another.
That is another great question. So if it's anything that is vision based, learns the trends based on edge detection. So what happens as and when you're working with with computer vision, whether using TensorFlow or anything else. What it does is that it takes each and every block, image, divides into block, and then lines it up into a single stream. Now, the bias you're talking about, it could be one or two things. One, it could be overfitting, where you have multiple variables that end up being so specific to the model that you've trained and completely useless to predicting the future or deciphering what it is that you want. So in that case, the bias could be built on the basis of what on the feature fields that you've selected. The other thing is, I have a case in point. There is this beautiful data set for, as I alluded before, of X-rays, chest X-rays. And I had some people wanted to come and use Tensor in Kenya, and they've been trying to get permission for that. And the reason why I think that is important is because the physiology and the design of the model of where you got your images from may not be applicable to somewhere else. So for instance, if we took chest X-rays for pediatrics in Netherlands and we bring it here, probably we will not get the same outcome. We have to factor local, or even better, plant diseases. If you're getting a sample of plant diseases from India, and we want to come and use computer vision or machine learning here, or TensorFlow image classifier, we may not get the same results. Because why? Different crops have different sizes and different colors, different shades, etc., etc., etc. So in that case, you are right. Where the model comes from, and I've been pushing for us to be able to have our own data sets that we can train. So that if you're talking about coffee diseases, if you're talking about any particular, we are basically working with models that we know and we can see. Does that answer you? I hope yes.
Yes, he or she says yes. And then we will provide the recording via email to those people who are having challenges.
Yeah, I think something that is coming up pretty clearly is that it's likely that our computer infrastructure is not, or our networking may not be up to scratch with working from home. But anyway, sorry for another day. All right, let me continue. I have quite a bit to go. So the other thing is save. Again, I speak from a position of pain of having had to redo quite a bit of work. And how we save, we just say save to CSV. I give the name, I say 01, cleaning, and then the important thing for us to do in this case is say index is none. So such that this index, this self-built-in index is not carried over onto the copy. And then once you do this, you can do an ls, and you can see whether the file, the 01 has been copied over. And if I am not wrong, it would be, it's not the final, it would be this one here, right? All right, let's get to the other interesting part, missing data. Now, if there's anything that can actually skew a model, again, it depends on what it is that you want to, and my apologies if I sound skewed towards machine learning or prediction. If there's anything that can, actually even for analytics, if there's anything that can skew your outcome, is the number of missing data. And for missing data, there's a number of ways you can do about it. You can either kick it out altogether, especially when you can't infer the outcome, or you can infer based on the mean or on the average. For example, you have especially anything that has a Gaussian distribution, you can more or less be able to predict if you have two categories, men, women, and then you put the age, you basically, if there's something that is missing, like men, say you have height, you can then be able to impute that without largely affecting the outcome. And I know this is going to result to a huge debate, but I'm ready for it. All we're saying is that you can be able to infer, but in some cases, there's absolutely nothing you can do. One thing you cannot do, you cannot ignore missing data. So what you do is that I have that very interesting function there, that basic, not function, that calculation. And this is about the easiest way that I have seen to be able to find out where data is missing. And in this case, we find that the registration number has 51 missing records. Is that true? We can come and say, show us the one that is null. So what this does is that it shows us the one that is NaN, not a number. And this will give us each and every one of them. So we can go through this and decide what do we want to do. You know what? If we look at this number of records, 51 records, those are too many, because there's some areas that don't have facilities. And if you look at them, these are level 2, level 3, level 2, level 3, level 4. So if we remove some of this, if we say drop, one of the options you can do is drop NA. If you drop, you may affect what the entire data set looks like. So what I would recommend in this case is that wherever there is not a number, we replace it with a 0. And that's what we do. However, that's not the end. We go back to registration again, and we find there's some that the registration number is none. Right? Now we have registration numbers that are digits and others that are, and in this case, we have a string. So what I'd opt for that, and I would do, is that I'd also change that to 0. So again, what I'd like doing, this is my insurance policy, is that I'll use a string function, I'll say replace none with 0, and I'll go for that. And then it will show me, yeah, there are quite a number of them that are 0, and then after that is when I will replace the values in place. Again, I will look at the numbers and I realize, yeah, none of them, most of them. So these, no matter, they're showing as though they are numbers, but they're not numbers, they're strings. And the way to tell is the quotation marks before and after. That's what shows you they're actually strings, right? So you cannot treat this as though it's a number. You can't deduct one from the other. You can add, or you can, no, you cannot. You'd have to convert the type, and we will see how that is done. And again, once you're done with this, save this. So what I do is that I increment to number 2, and then I would say save it, and then also, just confirm that it was saved. So that's number 2, and you can see cleaning as well. Number 2 cleaning, so we go. So literally what you're doing, you're providing a footpath back again to where you started and where it is that you want to go. Now comes the interesting part. Say we decide, you know what, I think we've seen so many numbers in that registration column part, and what we want to do is we want to convert everything to numeric. So if we do, my bad, if we do health DF registration, if we look at that, we tend to see as if all of those are numbers, right? So why don't we convert this into a number for whatever reason? So I call Pandas function called to numeric. There are other ways you can do it. You can do, you can convert data, and then you say, go for it. And what do we get? We get an error. It says you cannot convert everything to numeric because at position 24, there's a string called A42 to 25. And you say, okay, let's have a look at that. We come here, and true enough, the registration number is 4225. So what I'd like to do is show you how do we change that? How do we access that one? How do we access this value in calling it? So use IAT, index location, and gives us, that's number 2. What I wanted was number 01. I wanted number 1. And there we are. It's number 2 before because there's a field we dropped. And what I want to do is that I want to come and replace this. And this is purely for demonstration purposes. I want to change the value of that to drop the A so that it's just 225. And I would say that done. So let's check that again. And voila, it's changed it. So this is how you access a specific field and alter it. But now the crazy thing is that if we come again and run to numeric, it tells me not so fast because at position 48, there is this number here, /19. All I'm saying is I'm doing this for demonstration purposes, is that at the end of the day, sometimes you have to go through these iterations over and over and over again until you clean your data set. Or sometimes you decide, you know what, I may not need this field as much, but if you have numbers or you have floats or you have a mixture of numbers and strings, you have to do this literally for every single kind. You can write a function to clean this up, but there's no other way of cleaning it up, right? But then you have to do that over and over again. All right. So assuming we have finished, we can now come and start looking at each and every field, starting with the ones that we know. For example, I will do unique for counties. Where's Tarakanidi? I can't find it. And I know it's somewhere here, right? And then, so we know for example, there are 47 counties. And you can check and see how many counties there are. This allows you to have an insight into the data even more. Same thing, constituencies. You can see the list of constituencies there, and you can see how many constituencies are there, and say, yep, 290. And then you still can check whether you have any more missing functions, and realize that you don't have any more missing functions. The last step is normally converting the data types. So for instance, if for instance, you realize that registration number should be an integer, then we have to do everything that we can to convert to an integer, right? And that's the last step. And in my case, more often than not, when I get to that point, what I will do is that I'll save the final copy. I will ensure that it's there. I will read to see that it's exactly what I need to, and probably what I will do is that I will run another instance of Pandas Profiling. And once this is done, I am almost sure that before we do that, we get there. You see, we have fewer variables. The numbers are still the same. We go through the warnings, supported number. Review the document. And then when you get to the next step, what I will do is that I won't do analysis on this same notebook. I will then go to a different notebook and start a notebook just for the analytics part. So that way I have clear lines. I know this is how I cleaned it up and this is how I analyzed it. Because I also don't want it to be so long that I lose my way. So in a big, very, very big nutshell, that is my work process. And I'm ready for questions.
Okay. Oh, there's someone who says we can't hear anything. Maybe the connection had a problem, but there's someone who has asked, Mark has asked, between NumPy's function and Pandas function for converting data types, which is faster when considering performance when dealing with big data?
Again, and this is something I learned from my Linux days. There's always been more than one. There'll be more than one way of converting. I have found myself drawn towards NumPy. I know you can convert using. Sorry, I'm drawn towards Pandas. You can convert using, but if you want to see the performance difference, you can always add a time decorator, and see which one gives you better throughput. But there is always more than one way of converting data types.
Someone has said the way you were cleaning up the columns is really smooth, and the laziness challenge is great to know. I am excited.
My pleasure.
Oh, he says he can hear you now. Okay. What tips would you give anyone who has their own data sets and they currently have challenges, especially when the data has integrity issues? For example, the systems they're currently using are not in sync. So the data has, for example, like the columns you had, there's, what is it? It's like, for example, on one column, the system, on one system, it identifies you as your name. And then in another system, the details of that particular person on the other system are not in line. But you're required to clean up in the integrity of the data to make sure that whatever output you have down here is actually consistent. So what tips would you give someone who is working with different systems with challenges of tagging, of names, of titles? Yeah.
That is a great question. Unfortunately, I can't remember the library, but there's a library, I think it's called Fuzzy. I can check out Python, it's called Fuzzy. So what Fuzzy does, it tries and matches, because sometimes you'll have addresses, like you have two different company names and addresses. So what it does, it looks for the ones that look similar, or sometimes they have a change in case. Please remind me, Marcy. I would love to give you an exact answer and send you a link to how to clean up. But you know what? The more challenges you get, the more challenges you overcome, the better you become at your work. Right? So embrace a challenge. Some of it looks absolutely thankless. One of the challenges that I took up to myself not so long ago is that, the census came out sometime. What I did is that in true government function, everything comes out as a PDF. And there are tons and tons of tables using amazing information. So I took upon myself to say, you know what, I'm going to extract all these tables. So I went to the house. I got a library called Tabula. And then Tabula did an amazing job in extracting the tables, majority of the tables. And then from there, and don't forget that they are being set by page. So it's not putting them together. So you then have to start putting them together and using PD concat and PD merge. And then at the end of the day, you merge different tables, put them together. And by the time you're done doing the first 10, 15 tables, you almost have an idea of how it is that you want to do it. And the problem is that I could not write the function for that because there are different tables. On one side, we have household income. On the other side, we have age demographics. On the other side, we have the number of degrees people have taken and what the water source is. So you can only do so much that each and every time you work on the data, you're doing something, you're basically learning as you do it. So what I'd say is that I'll get to the library for that, but no matter what data set they throw at you, clean it up and clean it good. That is what is going to get you really, really good in analytics. It's also going to make you really, really good in the data science part. And if you move to the prediction, you'll also be really, really solid when it comes to that because you know the data intimately. All we are doing right now is just getting to know the data. And by cleaning it up, we have a right to be able to analyze it and get the meaning that we are looking for or is expected of us.
No other question.
All right.
Any add-ons you'd like to add? Or someone has asked, we are talking about large data sets. How would we handle sample data sets?
I did not get that.
Maybe, Cecilia, would you like to unmute yourself and maybe explain the question? You can unmute. Let me. Yeah, you can talk.
She's in a noisy place.
Yeah. Oh, okay.
What I would say is that I've come across libraries that, like, say you have this is what I do. If I have a very, very large data set, I use Google Colab. And there's a bit of work to put upfront in mapping the collab to your Google Drive directory. But once that is done, like that's what I did with the data set from the national population, is that I moved it to Google Colab and then I pointed it. There's some really interesting tools that allow you so that Tabula is then accessing from your Google data set, from the, how can I say, yeah, it's accessing through your Google Drive. So then you're not using your own resources, you're using Google resources. And then when you're done, you basically download the file that you worked on, and then you can work through that.
There's a question.
Yep, I've seen that.
Please take us through how to map Colab to Google Drive directory.
I will share the tutorial with that. It's a bit, there's a bit of work to be done, and not to mention that I'll be exposing my own Google Drive. So I will share that.
So she says, Cecilia, who's asking, we are talking about large data sets. How would you handle the data sets? I currently have a sample data set and working on that to later inform a wider study.
Okay, I'm wondering if it's from a cleaning perspective, probably you'd use a smaller data set so that you can run. What I would recommend that you do, especially if you do this over and over again, is turn these steps into functions. So for example, if you're cleaning a particular part, you basically define a function where you do the data set, and then you, as an argument, you pipe the column you want to clean. And then you have the steps under that function. So that way you end up cleaning each and every one through a function, and you do a loop for that particular column. Especially if it's something that you do over and over and over again. What that means that if should you come to a point when you have a larger data set, is that the same function that you use will be applied on the smaller data set. Right? So basically what you're doing, you're using a smaller data set as a way of cleaning up and tidying up and making sure that the methodology is in place. Then once that is done, you then can now upgrade and turn everything into functions, especially if you're dealing with the same data over and over again.
She says she will try that. Interesting. Someone has asked, what's the largest number of rows in a dataset that you'd have to clean?
That is another brilliant question. Now, it's not all the data in a particular data set that will be applicable to what it is that you're trying to do. However, if you anticipate that there will be a large demand for that, I would say clean up the first 4 or 5 different types, create a function, what I just told Cecilia a few minutes ago, and then you can run each and every column through that. Sometimes and this is a downside to my methodology. I'll be the first to poke holes on it. Sometimes I will clean more data than I'm willing to use. But also I'm trying to balance the chance that what if I've asked questions or I have need of this data, do I then have to get myself back again and clean that? So I just want to make sure that I have a clean data set, whatever questions that I want to answer. For example, how many level 2, level 3, or level 4 hospitals? In fact, this data set in particular will give you a clear understanding of where we are as a country, right? And some of the questions that I saw and answered through this are really, really scary. For example, we have, for level 6 hospitals, the referral hospitals, we have Kenyatta, we have Moi Referral, we have Mwai Kibaki in Nyeri, and then we have Madare Mental Hospital, we have the spinal injury as number 5. I don't think in the entire country we have more than 6 level 6 hospitals. Not all counties have a level 5 hospital. So for example, if you're dealing with the crisis that we're looking at right now, we then are having to really, really look at what our health infrastructure looks like. So then the next steps of this would then would be the next steps of after EDA. Let's get into analytics. Let's ask ourselves some questions, and then the highest number of health facilities is a place called Ainabkoi. Why? Because that's where Moi referral is. So there are all these labs. There are all these dispensaries supporting the larger hospital. So we'll always see those kind of clusters happening. So if we decide, for example, because of the health crisis we're in, people are not going to level 5 and level 4 hospitals. It means then we have to equip level 4 hospitals and level 3 and 2 hospitals to take care of primary care, because those are still there. There's still guys getting cholera, and we saw that. There's still guys who have lifestyle diseases to deal with. So yeah, it's until we know this and we have an idea of what it is that we're doing and we clean it well that we can start answering the questions. But that is a very long answer to what you asked. If you have a lot of questions, if you have a lot of data sets, you would have to, a lot of columns, you'd have to find ways of cleaning it up to anticipate both current and future needs that you may have.
The last question.
Mm-hmm.
How would you handle cleaning of non-Unicode data?
Kevin, give me an idea of what you mean by non-Unicode data.
As he responds,
Mm-hmm.
Lillian says in the chat section that you share your contacts.
All right, I will do that.
Kevin, you can even ask the question using voice. You can unmute yourself. Okay, as we wait for Kevin, what tips would you give an analyst or a junior data scientist who is starting out?
Perfect your cleaning data.
Why is it important?
Because everything else is just like the good book says, all other commandments lie on this one. Thou shalt clean your data, you shall be so good at it, then that way you will be really, really good, because you're going to spend, it doesn't matter what you do, you're going to spend between 80 and 90% of your time, whether you're an analyst, whether you're a data scientist or machine learning engineer, you're going to spend 80 to 90% of your time cleaning data. And the better you become at cleaning data, the better you are at feature engineering, the better you become at deducing trends, seeing the way data behaves, etc., etc. Because then you look down the line. For example, sometimes I would work, and I know the data pretty well. And at the end of the day, towards the end of the line, you see an outcome and remember, no, I didn't. That is not what I saw. I'm missing something. Then you go back and you can see exactly where you made a mistake, and you can fix that. But if you're just analyzing data that you've gotten, then I don't think it gives you as much insight.
He says the data lacked delimiters. That's Kevin.
Okay, I see what you mean. Like say what? Packet capture information? What I would do in that case, if you're talking about cleaning that, it's a bit tricky, because then one, it'll be high dimensionality. And the second part, I'd love to have this discussion with you, Kevin, offline, and see what you're talking about in particular. And then we see what specific, because I need to have a better view of the data, but I'd be more than glad to help you offline.
And then
all right,
the last question by Anne Moshiri. What's the best approach to handling missing values?
That's great. That's a great question. One, find out whether it affects your outcome, your eventual outcome. If it does, then you can impute the missing value. First, actually, the first thing you need to find out is that particular column important to your analysis or not? In our case, you remember our column for service name, it had no values. If it has no values, we cannot use it. That's why I dropped it. This one in particular here, right? Because we have nothing to go by, so that I'll drop. However, if you're looking, for example, at, let's say we're looking at cost, and we figure cost is a very important aspect. We don't have costs over here. Excuse me. Then you figure that cost is important to what you're doing. What we do is that we would end up using the mean or the median to deduce what the value it is. So for example, we would look at a particular cost, we would look at a constituency or a county. We see what other, excuse me, we see what other hospitals by level are charging. And then we look at the level of this current hospital and we can impute that. So that way you can either use median or you can use mean. So that way we end up being within the ballpark of the amount we are looking at. However, if not, you can just you can either impute or you can either infer, or you can do away with trying to, or you can try and drop it all together. But those are your two options. Thank you for helping, Anonymous. All right.
Versus inference when dealing with missing data.
Yes. I would say you can either, for imputing, you can, what's the best way to go about it? What I'll be most comfortable is either you either infer based on the sample that you have, or you can impute. You can look at the trend within a particular data set and see what values you want to fill in. You can either deduce or you can either drop. Actually, that's the easiest way. You're either going to drop it altogether, or you're either going to fill that value based on whatever the trend is within a particular data set.
So you were saying.
All right, Mercy.
You were saying.
Go ahead.
The tips. First of all, is you really need to perfect in cleaning. Maybe we make them 3.
Perfect cleaning. Mm-hmm. Ask yourself good questions and challenging questions. Mm-hmm. And get as many data sets as possible. Mm-hmm. There are many local data sets. The population data set from National Population Council, National Population, and it's a beautiful data set. Mm-hmm. It is. I would not recommend it enough. Mm-hmm. Get that, and then also next step, start visualizing. Mm-hmm. Right? Jump on using Plotly. Use all the tools that you can get in, and then start visualizing and start imagining the questions that can come out of it, and then add in interactivity. And yeah, that should be a great place to start. But there's no other way we can do it. We clean it and we tell the story about it. And let me also say that the whole reason why we do all this is so that you can present our findings. Sometimes we get so caught up and so excited about the cleaning and the analytics, and we miss out the last part, which is definitely the most important part. How do we present our findings? So we when somebody asks us the story, we need to tell them what it is that we started, and what we did, and and why we are saying what we are saying. And when that is in place, then you complete the circle from acquiring the data to telling the story about the data. And more often than not, we don't make recommendations. All right. Thanks, Mercy, and thanks for everybody for joining. Back over to you.
Last question. I promise.
Okay. All right. Okay.
Della is asking, how can one hydrate a text?
Hydrate a text?
Mm-hmm.
I have no idea. I have to read up on that. I don't know what that means. I'll be totally honest with you.
Okay. No problem.
Yeah. All right.
Thank you so much, everyone, for tuning in. Thank you, David, for presenting. This was really, really informative, and the good thing is that it was practical, so most people will have at least a technical takeaway. Thank you. Make sure you follow us, Botlab, on social media. Next week, we'll be talking about data integration. How do you integrate different systems? Because sometimes you clean up what you have integrated. Not everything is in a straight line. So next week on Thursday, same time, we'll be having a session on data integration. Follow us so that you can have the link when it's ready, so that you can sign up. Thank you so much. Have a lovely evening. Good night.
Thanks, Marcy. Good night.